ప్రియాంక అని చెప్తుంది ప్రియాంక అని చెప్పి చెప్తుంది
అంతే.
Hello my dear students, welcome to one more amazing session from Sri Chaitanya Academy. This is Suresh, Faculty of Chemistry. So आज हम चर्चा करने वाले हैं ऑर्गेनिक कन्वर्शंस बोर्ड से नीट तक. Preparing for your NEET examination as well as your board examination, and in 2026 you are in extreme turbulence. क्या करना, कैसे याद करना, everything I want to take you in a consolidated way in one session, in a single shot, in one short series. So dear students, stay till the end of the session and take a pen and paper and write the notes and the noteworthy important points and tricks and tips also I am going to give you. Organic conversions kaise karna. When you open the organic chemistry book, you will be having hundreds of reactions. How to memorize this reaction? Who asked you to memorize the reaction? No. Better you use how to use the reactions, right? So, right from alkane, alkene and alkyne, alkyl halides and haloarenes, alcohols, phenols, ether, aldehyde, ketone and carboxylic acids and amines, and every point कैसे reactions कैसे इस्तेमाल करना, कैसे questions भी आ सकता है, NCERT related reagents and everything I want to give you. Those students who are online, please like this session, share with your friends and subscribe to this channel, right? Hi Surya Pratap, I think you are Betu, right? Happy to see Raj Chaudhary, hello. So NEET 32585. So organic chemistry कुछ समझ नहीं आ रहा है, कोई प्रॉब्लम नहीं बेटा. आज सेशन में आपको ऑर्गेनिक केमिस्ट्री में सिंपल ट्रिक करवाना चाहता हूं बेटा. कैसे सेट करो? यस, you start doing converting organic molecules. Yes, definitely you can do it. So शुरुआत से शुरू करता हूँ. So organic conversions, a special slide for you. You connect. I like this particular diagram. Why this picture I like it? Because you can see various dots. When you connect these dots, now you are going to get a beautiful picture, isn't it? Yes, I am here to help you to write all kind of any kind of reagents. And so when the organic chemistry conversion is coming, you can get a direct question or indirect question. So a direct question में कौन सा reagent कौन सा product दे सकता है बस. But sometimes you will be asking a question in direct way where you will be giving A, B, C that you have to go through as route mapping. So बच्चों, here I want to give you the organic chemistry conversions is of majorly 4 types. So majorly 2 types I want to say, aliphatic conversions and aromatic conversions bus. In the aliphatic conversion, you have 3 versions again. The conversion in which the carbon number is the same. I mean to say reactant में जितना कार्बन होगा product का में उतना ही number कार्बन होगा. And ascending conversion, the conversion in which the product has more number of carbon atoms. And descending conversions in you have the product has less number of carbon atoms, right? So let us see all versions of the conversions and all named reactions also discussed and all NCERT related conversions and some questions from the previous year. So Violet, take a pen and paper. Everybody, come on, let us see. When you see the big picture of the organic chemistry conversions, you are going to see like this. You Google it, you will get this image. And you go and see any textbook, you will get this image. And you ask any teacher, he will write something to make this image. Even I don't want to give you that confusion. And it is a mind map, beta. It is a mind map. You have to travel through this mind map. Say an example, this is an alcohol. Na? In this alcohol, you see here OH group is there. And OH group ka kaise handle karna? And it is going to react with various, so react with PCl5, OH group Cl banega. Like that, this is an introduction slide. I don't want to take the total class based on this only. So whenever you have an opportunity to see this kind of slides, you just identify इससे क्या हो रहा है. You see bromine KCN से cyanide बन गया, so that cyanide hydrolysis करके carboxylic acid बन गया. You observe the change. When you have the change, you are going to learn the things. So सारा रिएक्शन का जो ट्री है ना, टुकड़ा टुकड़ा करके आपको सिंगल सिंगल स्लाइड बना के आपको एक्सप्लेन करना चाहता हूं. राइट, एवरीबॉडी टेक ए थम्स अप एंड फायर इमोजी बेतु. सो होप यू एंजॉयड योर Pongal, Lohri and everything. Now we are entering into board examination preparation as well as NEET examination preparation. So NEET examination and board examination करने के वक्त में NEET नहीं छोड़ना है. Parallelly how to prepare it. Yes, I have the idea how to do it, and let us go into the details of how these conversions are made. Ascending conversions, ascending series. जैसे conversion आता है ना आपको, reactant से product के लिए carbon number बढ़ना है, right? So that is reaction of alkyl halide with KCN. Whenever alkyl halide is reacted with KCN, you are going to get alkyl cyanide. So I mean to say alkyl chloride, you are going to react with KCN. जैसे KCN अब इस्तेमाल कर रहे हैं ना, you are going to get ethyl alcohol or acetic acid, and you are going to get some kind of solvents like that. When you see this kind of solvents, no, don't worry, ये solvent करता है क्या? Solvent is the medium where the reagent is reactant is going to convert into the product. You are going to get a cyanide, and so उसमें n number carbon है, इसमें n+1 number carbon है. So game is over. Now you can say convert bromomethane to ethanol. How to convert bromomethane to ethanol? So bromomethane में कितना नंबर कार्बन एटम है? Bromomethane CH3Br. Now simply I want to use this RCN. You are going to say KCN and acetic acid. You are going to get CH3CN better. Yes. Now हमारा पास जो है ना साइनाइड ग्रुप है, जो साइनाइड ग्रुप है ना थोड़ा सा हाइड्रोलाइज करना चाहता हूँ and ethanol करना है. So I want to use lithium aluminium hydride. So you will get cyanide is immediately converted into CH3 CH2 NH2. So don't worry beta. So this is a reducing agent. आज हमारा क्लास में सारे क्या सारा oxidizing reagents and reducing reagents and how they are going to be used, everything I want to give you in this session. Stay tuned. Every session, every slide in this session is going to be super important. And this is the primary aliphatic amine. When you add NaNO2 and HCl, that I want to say HNO2, you are going to get alkyl diazonium salt. Alkyl diazonium salts are going to be super unstable. They will be automatically hydrolyzed. You are going to get their corresponding alcohol CH3 CH2 OH. So every reagent that I am using here, it is there in the NCERT. 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 Question कहाँ से निकलेगा? NCERT से निकलेगा बेटा. And this is the way you need to do. हमारा पास ethanol का पूछा, ethanol is formed है क्या ना? So dear children, please follow us and stay tuned till the end of the class, and I want to give you the further conversions and the method. I want to give you a question and conversions. Everything is ready, and I'm expecting your doubts from you. Use the chat box and can enhance your knowledge from this YouTube channel. And let us see in the ascending series, ये दूसरा वाला है, how will you convert methane to ethanoic acid? अरे बेटा फिर भी cyanide इस्तेमाल करो बेटा. I will tell you how to do this. Clear? So methane CH4 and ethanoic acid. Methane में 1 carbon atom है, ethanoic acid में 2 carbon atom है. So that I want to just use Br2 In the presence of UV, you're going to get CH3Br. And this bromide can be converted into cyanide by using KCN. हमारा previous slide का हिसाब से ब्रोमीन हटा दो, न्यूक्लियोफिलिक सब्स्टिट्यूशन रिएक्शन शायद SN2 होगा, CH3 and it is going to be CM, right? That's good. And whenever cyanide is hydrolyzed na, acidic hydrolysis, and you're going to get CH3 COOH, ethanoic acid ban gaya bas. And you can say this is a indirect conversion. You can say A gives rise to B gives rise to C gives rise to D. इससे ऊपर क्या पूछेगा? And in the all the reagent you see here, it is there in the NCERT, it is there in the NCERT, it is there in the NCERT. Open NCERT and correlate all these reactions, and in this session, in my presence, you are going to learn everything and everything. और एक and बेटू अगर कुछ डाउट है ना तो बोलना. And NEET 32585 नाम क्या है बेटा? And I'm more comfortable to say your name rather simply saying gaming, gaming and NEET, okay, aims kind of. So let us be free and interact together. This is a live interactive session, not a recorded session, and you can use this session for better perspective. And next one in ascending series, you can use Wurtz reaction. What is Wurtz reaction? So it is use of the reaction make a product having a double number carbon atom than the reactant. Alkyl halide react with the sodium metal. In dry ether, you are going to get higher alkanes. You can see RCl and RCl when it is reacted with the sodium metal, okay, and it is going to give you ascending version, double the number carbon atom milne ke liye, you are going to get R and R. So higher alkanes are formed, double the number of carbon atom. If you want to increase one carbon, better use KCN. You want to increase the number to double, better you use Wurtz reaction, right? And the purpose also solved. If you have any doubts, you can ask me. This is ascending series और एक है using Grignard reagent. अरे बेटा Grignard reagent जैसे reagent है, it is going to give you the best out of all conversions. Alkyl halides, Grignard reagent. What is a Grignard reagent? जब alkyl halide है ना, alkyl halide when it is treated with magnesium in dry ether, you are going to get RMgCl. So Grignard reagent is a great reagent and it is a good nucleophile and excellent base, a strong base, and it can give you when this Grignard reagent, you can have so many reagents. Grignard reagent or MgX when it is treated with formaldehyde followed by hydrolysis, you are going to get a primary alcohol. Okay, that is the first use. You can see carbon atom number is increased. Grignard reagent, when it is reacted with any aldehyde other than formaldehyde, you are going to get secondary alcohol. Fine. You can also see Grignard reagent, whenever it is reacted with a ketone, you are going to get a tertiary alcohol. So Grignard reagent के जैसे you can prepare primary alcohol, you can prepare secondary alcohol, you can prepare tertiary alcohol. And Grignard reagent is also used for carboxylation and carbonylation. आगे आने वाले के स्लाइड में ये डिस्कस करने वाला है. Grignard reagent is जैसे reagent है, it can be used to convert anything, especially for the, it comes in the alkyl halides, it comes in the alcohol, it comes in the carbonyl compounds, and even more in the cyanide reactions and everything you are going to see in today's class. I want to discuss about the Grignard reagent in a super awesome manner. take a pen and paper, write all the noteworthy points, okay, that I want to give you the best out of this Grignard reagent and other conversions. Now let us see in the ascending series carbonylation process. I am giving you all the reactions that are there in the NCERT. So you are here with me and I am presenting from Sri Chaitanya Academy YouTube studio. बोर्ड एग्जामिनेशन प्रिपरेशन, नीट एग्जामिनेशन प्रिपरेशन साथ में जा रहे हैं. गौरव, दिस सेशन इज मोर ऑलमोस्ट और 1.5 घंटा चलेगा बेटा. ओके, आई विल कंटिन्यू दिस सेशन टिल 2 hours, whatever, till the end. I am going to continue this till all the reagents and reactions are completed, and I want to close this session once every student gives the consent that your doubt is clarified. So I want to close this session by 1 o'clock. Is that okay, Gaurav? So carbonylation, this is oxo process. This is an aldehyde. Whenever it is treated with a Grignard reagent, I think it is visible here, and the Grignard reagent is going to attack here, so that you are going to get a propanol. So this is called oxo process and ascending series carboxylate reaction. So what is the carboxylation? Addition of carboxylic group is called carboxylation. I will tell you this Grignard reagent RMGX, I said it is a good nucleophile. So whenever it is treated with carbon dioxide, carbon is partial negative charge, positive charge here, so that it is going to attack here. Don't say it is a mechanism, just polarize the molecule and it can show everything. Gaurav, and you're going to see the formation of R, C, O minus and MgX and C double bond O, and it is further hydrolyzed to give rise R, C, OH and double bond O. Carboxylic group is being introduced in this reaction. So I want to say it is a carboxylation. What is meant by decarboxylation? Carboxylation means addition of carboxylic group. Decarboxylation means removal of carboxylic group. Okay. Now in the ascending series, reaction with HCl with aldehyde to form alpha hydroxy acid. That is a super important cyanohydrin reaction. Now you can see HCN, okay, to aldehyde or C double bond O, it is an aldehyde, right? This aldehyde reacted with HCN, so HCN, Cn minus Hu plus, so that I can say this cyanide is going to attack and carbonyl group, क्योंकि ये negative charge है, positive charge है कि ना बेटा? Surya Pandit, yes. Now you are going to get R, C, O minus and H and Cn. जैसे sp2 जो कार्बन एटम है ट्रायंगुलर प्लानर sp3 टेट्राहेड्रल बन गया, right? Now this is what is called as cyanohydrin. Okay, this is what is called as cyanohydrin. You know the application of cyanohydrin? Surya? Right? This cyanohydrin can have 2 applications over here. Let us talk about these 2 applications. You can directly hydrolyze this. दिमाग में है, जब साइनाइड हाइड्रोलाइज करते हैं ना, कार्बोक्सिलिक ग्रुप बन गया, so that you are going to get COH and CH and COOH. ये COOH ग्रुप का हिसाब से ये कार्बन अल्फा होगा, अल्फा में हाइड्रोक्सी ग्रुप है, so that you can say अल्फा हाइड्रोक्सी एसिड बन गया, and this is going to form a new chiral center. This is a chiral center, so it is optically active plus and minus. Okay, pair of enantiomers मिलेगा, या साइनोहाइड्रिन, हाइड्रिल नहीं है बेटा, करेक्ट कर दो. सो दैट इज द यूज ऑफ यूजिंग चार्ट बॉक्स. अगर कुछ गलती होगा तो आपके तरफ से मैं सही करना चाहता हूं, क्या पंडित जी? राइट. सो दिस इज गोइंग टू बी ए पेयर ऑफ Dextro and libo-rotatory compounds said to be enantiomers. What are enantiomers? A pair of optically active isomers which are non-superimposable mirror images are called enantiomers. These enantiomers has similar physical properties as well as chemical properties, so that it is difficult to separate by using simple physical methods. Enantiomers physical separation में नहीं होगा, diastereomers physical separation में हो सकता, right? So please connect with the stereochemistry as well. We will discuss this kind of reactions and so many noteworthy important points. And I want to say aldol condensation reactions to form beta hydroxyaldehyde and a ketone. Wow, it is a super confusing topic for the students. How many of you confusion with aldol condensation? चाहे ये aldol condensation self aldol होगा, intermolecular होगा, intramolecular होगा, and whenever an aldehyde having alpha hydrogen is treated with dilute alkali, it is going to form a condensed product that is called aldol. So let's see. That's very good, super. And let us see, this is CH3 and CHO, and two molecules are used. And what will the product when it is treated with sodium hydroxide? That is the biggest problem. Don't worry, I am going to give you the trick to solve this. So two molecules इस्तेमाल किया जाएगा ना, and I will give you the mechanism and the trick as well. Stay tuned. Here one molecule CH3 and CHO. Whenever you treat with OH minus, so this is your alpha hydrogen. So this is going to abstract alpha hydrogen to form a carbanion. So this is your CH2 minus and CHO, and this act as a nucleophile. This act as a nucleophile. This nucleophile a दूसरा molecule को काटना है, कैसे? देखो, it is going to be with one more molecule. Two molecules are reacting na, one molecule with yellow, another molecule with white. Okay, so let's see, CH3 and C double bond OH. Now it is a partial negative charge and a partial positive charge. So nucleophilic attack होगा. जब nucleophilic attack होगा ना, it is going to be like this, right? So अरे इतना complicated दिख रहे हैं? नहीं, complicate नहीं. एक trick देना चाहता हूँ आपको. At the end of this scenario, you are going to get CH3 and CO minus and H, and it is going to be CH2 and CHO. Okay, now it is hydrolyzed to give you the product like this: CH3, CH and OH, and it is going to be CH2, CHO. This is what is called beta hydroxycarbonyl. This is what is called aldol, right? This is what is called aldol. So, Surya plus Asta. What is this? Surya plus Asta. Okay, let us talk about this aldol condensation. When this aldol is heated, so what is going to form? There is a water molecule is eliminated. CH3, CH double bond, and it is going to be CH and CHO. And इतना complicated process है. मैं आपको एक simple trick देना चाहता हूँ पंडित जी. Surya, and you can see this is the one, CH3 and CHO and CH3 and CHO. ये trick में क्या करना? You see, one is aldehyde group, another one is a alpha hydrogen. These two are kept, and you just remove the water molecule, and water molecule is removed, so that wherever you remove the water molecule, make a double bond over there. So you are going to get CH, and here it is CH and CHO. So this is my trick. This is my trick. See, इतना complicated mechanism से same product बनाई दी आपको. How many of you like this trick? During examination, चाहे CBSE एग्जामिनेशन, बोर्ड एग्जामिनेशन, ICSE एग्जामिनेशन एंड नीट एग्जामिनेशन में भी ये ट्रिक आप इस्तेमाल करो. Thank you very much. And some more tricks, wait till the end. If you have any doubts, please let me know. Betu, how about your preparation? Here, when we started this channel and this series, so many students are regularly attending. One of the student here with me right now in our class, Betu, and however, the student has so many problems, health issues. Still, she is using this YouTube channel as a platform and doing well in the NEET examination preparation. So, Betu, how are you doing? And our examinations are still till close here in the mid of the January. So, wait for till May and lage raho and come out of this examination with flying colors, beta. Right? All the best, everybody who is right now in the class, expecting you to be great in the examination. So, enjoy the class and increase your knowledge and confidence with the content we are giving from Sri Chaitanya Academy initiative by the Infinity Land. This is Suresh, and please, those who are online, please like the session, share with your friends and subscribe to this channel. So ताकि आपका आगे क्या क्या sessions है आपको bell icon button दबाना, so that you will be getting all the notification. Okay, now descending series. So what is a descending series? So a conversion where carbon number is decreased, that is called descending series, right? That's good. Hoffman bromamide reaction, that is a very important. So what is this Hoffman bromamide reaction? Simply I want to say RC double bond ONH2. When you use the reagent just like a potassium hydroxide or sodium hydroxide and Br2. Okay, I don't want to write the total reaction. Okay, just what I can say, ruthlessly you can remove C double bond O, right? So that you are going to get RNH2. So primary amine अमाइड से निकला, चाहे इसका n नंबर कार्बन होगा, प्रोडक्ट में CN-1 नंबर कार्बन मिलेगा, right? This is a descending conversion. My NEET preparation is going great. That's fine. Those who are online, please like the session better. And you can see how you prepare methanol from ethanoic acid. Methanol, it is going to have CH3OH and ethanoic acid CH3COOH. और इथेनोइक एसिड में दो तो कार्बन एटम्स है, मेथनॉल में सिर्फ एक ही कार्बन एटम है. सो आई वांट टू डिक्रीज 1 नंबर कार्बन. एक खास बात है बेटा, सिंपल. इथेनोइक एसिड CH3COOH. Simply I want to use NH3 and you heat it, so that you are going to get is a base and it is going to be an acid and it is going to form C double bond O NH2. So ethanamide is formed. What is this? Ethanamide, and simply use potassium hydroxide or a sodium hydroxide and Br2, so that this is removed. So CH3 NH2, you got it, right? Methanamine. Now you use some 1000 question practice more, upload in PDF format. Okay, Raj Chaudhary, it is there in this Telegram channel beta. Definitely you are going to get it. It is near about 14 no, it is about a 14 hour session or no, I don't remember, and it is there in the Telegram channel. So it is there in the YouTube channel. You can see under the heading of the YouTube channel, you can see in the description box Telegram channel, उसमें join करो and every session का PDF format का notes आपको मिलेगा, right? So you are going to see HNO2, you directly get CH3OH, methanol मिल गया. Any doubt? You can ask us. Definitely it is going to be a super awesome conversion. I am giving you the content and I am explaining the thing how it can be done, right? That is an excellent presentation for you. And descending conversion, decarboxylation reaction with sodium hydroxide and calcium oxide. So what is decarboxylation? Removal of carboxylic group is called decarboxylation. बच्चों देखो, this is what is called as a soda lime. Okay, whenever you have a carboxylic group, if you add soda lime, calcium oxide and the sodium hydroxide and you heat it, क्या करूँ मैं? कार्बन डाइऑक्साइड निकालना, बस CO2, कार्बन डाइऑक्साइड निकालना. So you are going to, whenever you remove carbon dioxide, you will get an alkane. You are going to get an alkane. Okay, one carbon less. Okay, so चाहे उसमें n number carbons होगा, the product में n minus 1 carbon होगा. Any doubt? Now here the rate of decarboxylation. NEET examination में थोड़ा सा application oriented questions होगा. NEET examination में, okay, rate of decarboxylation का हिसाब से रेट ऑफ डिकार्बोक्सिलेशन का हिसाब से एक क्वेश्चन पूछने की संभावना है. वो क्या? फर्स्ट इज डायरेक्टली प्रोपोर्शनल टू स्टेबिलिटी ऑफ कार्बोनायन. जैसे कार्बोक्सिलिक ग्रुप निकालने के बाद यहाँ पर कार्बोनायन बनेगा ना, ये स्टेबिलिटी का हिसाब से डिकार्बोक्सिलेशन रिएक्शन का स्पीड बढ़ते जाता है. एंड कार्बोनायन का स्टोरी अलग होगा. और एक दूसरा बात है पर बीटा कीटो एसिड्स decarboxylate easily. Beta keto acids decarboxylate easily. You need not have to add soda lime, simply heat it. So I want to say here it is a beta keto acid. Okay, cyclohexane, benzene mat bolna beta. This is a carboxylic group and this is a double bond O. एंड ये कार्बन एटम का हिसाब से ये अल्फा होगा, ये बीटा होगा. ठीक है, ये सिंपली हीट इट, you simply heat it, nothing you need to add and you are going to remove this कार्बन डाइऑक्साइड. आसानी तरीके से निकलेगा एंड आपको मिलेगा साइक्लोहेक्सानोन. साइक्लोहेक्सानोन, that is the important version and you just use this kind of tricks and tips in the session and you can get definitely very good score. So whenever you are writing a board examination, चाहे CBSE examination होगा, okay, 70 out of 70, and you have the chemistry in the NEET examination 180 out of 170 plus, 170 plus out of 180. That should be the target. So you think big. Okay, टारगेट पहुंचने के लिए मेहनत करो बेटा. आप मेहनत करने के ये जर्नी में हमारा तरफ से आपको हेल्प करना चाहता हूँ. राइट डियर स्टूडेंट्स, वन मोर क्वेश्चन हियर इन द डिसेंडिंग सीरीज, ओजोनोलाइसिस, एंड आई विल डिस्कस अबाउट द ओजोनोलाइसिस. इसमें आपको एक ट्रिक देना चाहता हूँ. You have various types of ozonolysis, oxidative ozonolysis and reductive ozonolysis. And let us talk about this is your alkene. When you just apply zinc HO3 and zinc and H2O, that's it. Zinc is a reducing agent. You can also use lithium aluminum hydride. Okay, you are going to simply see, break the bond here and you are going to say 2RCHO मिलेगा. And if you use lithium aluminum hydride, what you are going to get? So there are three types of things. Okay, if I use O3 and lithium aluminum hydride, you are going to get RCH2OH. This is reductive. And if I use O3 and CH3, COOH and H2O2, so what happens? It is an oxidative ozonolysis. You are going to get RCOOH. This is an oxidative ozonolysis, reductive ozonolysis, right? So various products, oxidation and reduction का हिसाब से I prepared 15 slides. In today's class we will be discussing all these. Fine? Any doubt, बच्चों? Any doubt? And haloform reaction. I love this haloform reaction here. Haloform reaction. Whenever you see R, C double bond O and CH3, whenever it is treated with X2 and sodium hydroxide or potassium hydroxide, sodium carbonate or barium hydroxide, whatever. So you are going to see meet haloform reaction देने के लिए ये condition जरूरी है. Methylated ketone, simply you break the bond here and you are going to get R COO minus and CHEX3. चाहे iodine होगा तो iodoform मिलेगा. So the condition is R methyl secondary alcohol. So these are the conditions to show iodoform reaction. These are the conditions to show iodoform reaction. Are you getting or not? Clear? So I expect a doubt from you. And methylated secondary alcohol and methylated ketones. And you know CH3, CH2OH is going to give iodoform. However, it is a primary alcohol. Ethyl alcohol is the only primary alcohol can give you the haloform reaction, right? And also formic acid also, however, it is going to be, that's a different story. That is, I'm talking about tolerance reagent. Okay, leave it. Waiting for your doubts. You guys, Pandit ji, Surya Pandit, Beto, Raj Chaudhary, those who are online, please. Anuj Gope, Madhya Pradesh, he is not there in today's class. Come on, next, oxidation and reduction. This is a super important. आज हम ऐसे discuss कर रहे हैं ना जो concepts. These are there in the NCERT and I am consolidating these concepts in one short session and I am giving you the best out of this. Right. So this is the way when alcohol is oxidized, you are going to get an aldehyde or a ketone. Aldehyde or a ketone, oxidation, carboxylic acid. Carboxylic acid reduction, again aldehyde, and aldehyde, it is going to give you the reduction, it is going to give you an alcohol. So let us see in a systematic way. This is your alkane. When you go for oxidation, let it be any oxidizing agent. Next slide I want to show you what is the list of oxidizing agents. Totally you are related to the NCERT. And this is the oxygen. ये दोनों का बीच में घुसा दो. You are going to get an alcohol, right? And आगे oxidize करो बेटा. क्या होगा? R, okay? And I want to say CH3 and CH2OH. That would be better. CH2OH. And it is going to be get COH and OH. Array, two OH groups cannot be present in the chemistry on the same carbon atom except chloral and anhydride. I will tell you. Right? Now you just remove the water molecule. So it is going to give you its corresponding carbonyl group, so that you will get R C double bond O H. Aldehyde मिल गया. If it is a secondary alcohol, you are going to get a ketone, right? And this is further oxidized. you are going to get RC double bond O and OH carboxylic acid मिल गया. You want to reduce it? It is reduced like this. It is reduced like this. It is reduced like this. So, oxidation and reduction are complementary, isn't it? So, this is the way you have to study. And oxidation करना कैसे? Reduction करना कैसे? समझे बेटा? So, that is the game. Oxidation and the reduction. H2O is a hydrolysis reaction बेटा. Right? So, हम चर्चा करने वाले oxidation and reduction. You have total आज हम अभी इस्तेमाल करो ऑक्सीडेशन के बारे में बात करना. OSO4 इस्तेमाल कर सकता है, ऑस्मियम टेट्राऑक्साइड और COOH peroxy acid. You see, not a carboxylic acid, peroxy acid. Methane only, yeah, you can get it from methane. Gaurav, you can get it. I'll show you. You can use KMNO4 K2Cr2O7. You can use chromic acid. You can use pyridium chlorochromate, and you can use pyridium dichromate. You can use Collins reagent. You can use MnO2, and you can use periodic oxidation, and you can use lead tetraestate. You can use ozonolysis. You can use selenium dioxide. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 oxidation reagents are there in our NCERT based oxidation reactions. उससे ज़्यादा भी है, we don't require it. Even lead tetraestate, selenium dioxide, it is excess. बट थोड़ा सा इतना सा एक्सेस सीखने तो अच्छा होगा नीट एग्जामिनेशन में. अगर कुछ कनेक्टिंग क्वेश्चन आएंगे तो हम हैंडल करना पड़ता है ना. हाउ टू रिमेंबर दिस, देयर आर सो मेनी. अरे 12 reagents ना. I want to tell all these reagents right now, Gaurav, and I don't want to show you the mechanism. I don't want to just give messy information. I will give you simple. A reagent क्या होगा, इसका काम क्या होगा, बस. Are you getting or not? Clear? So there should be adapt a method of studying. We teachers adapt a method of teaching. So बच्चों को आसानी तरह से समझाना कैसे. And you're being a learner, you just adopt a method from a teacher and whatever the source of the study you are doing. You develop a method where you are doing all these things in a simplest way and a smarter way. Okay? And don't work like a hard man. Work like a smart man. Right? How many of you agree with me? So गधे के जैसे काम मत करना बेटा, शेर के जैसे करना. Should be bold. Whenever multiple choice question comes now, A, B, C, D options, you need to inculcate what I say, a daring step. You need to take a decision. Option क्या होगा. So a decision taking tendency आपका आ सकता है अगर कुछ test series आप देने तो. Test series is also there. Okay, anyways, I don't want to bifurcate the current discussion. Let us see. So one slide for one reagent. Ready for that? One slide. So one thumbs up, fire emoji, शुरुआत से. Selenium dioxide. Okay, osmium tetroxide से शुरू कर दूं मैं. Right बेटा. Don't say I am so serious, I am so friendly, and I will help if any student ask a doubt. Beta, come on. Osmium tetroxide. Osmium tetroxide is as a reagent here. It is very important. You can see this osmium tetroxide. Yeah. Now reagent is OSO4 along with acidic hydrolysis के लिए NaHSO3 aqueous इस्तेमाल करना. इसका काम क्या करता है? It is going to be alkene to diol and 100% syn addition. What is the meaning of 100% syn addition? So if you say carbon double bond carbon. If you are adding from one side of the double bond, this is what is called as a syn addition. If carbon to carbon double bond is there, you are adding here, one is here, and opposite side, that is called anti-addition. You have syn addition and anti-addition. ये क्या बोलना चाहता हूँ, ये syn addition, ताकि इसका product जो है, this is your alkene. When you use OSO4 and NaHSO3 aqueous, so you are going to get, what is the product beta? It is going to give diol. So it is going to give you product like this, OH and OH. So that's it. So it is stereo specific. जब सिन एडिशन जाता है ना, CMTR इस्तेमाल करो. Cis alkene gives meso product, trans alkene gives racemic mixture, and anti addition na ATM का, and we will discuss the anti addition in the later slides. Anti addition to trans alkene gives meso product, cis alkene on anti addition gives racemic mixture, and stereochemistry I told you CMTR, and isotopic oxygen of oxygen is converted to diol. मैं क्या बोलना चाहता हूँ, and it is oxygen this is the oxygen. This oxygen of the OSO4 will be with alcoholic group. So you are going to get a NEET question maybe here. You are going to get NEET question maybe here. NEET में एक क्वेश्चन ऐसा आने का संभावना है. बस इतना ही, 1 2 3 4 points. Agree? It's a nice informative, right? And RCOOH oxidation, peroxide oxidation, and it is just like a previous one. This is going to be anti-addition. So reagents you can use peroxy acid like a peroxyacetic acid, trichloroacetic acid, metachloroperoxobenzoic acid. These are all the reagents, and it is converting just like in the previous one, alkene to diol. Alkene forms cyclic epoxide first, and this cyclic epoxide is going to acidic hydrolysis SN1 and alkaline hydrolysis SN2 का हिसाब से 100% anti addition होगा. And look at this, and stereochemistry CMTR carbonyl to ester Baeyer-Villiger oxidation होगा. Next slide में आपको दिखा देना. And you can see this is the one where this is an alkene. When you use MCPB here, you are going to get epoxide, cyclic ether epoxide is formed. Okay, cyclic epoxide is formed. This cyclic epoxide, it can be hydrolyzed. Okay, so maybe acidic medium होगा तो SN1 cleavage, basic medium होगा तो SN2 cleavage. So let it be any cleavage, you are going to get an diol 1,2 diol. So this 1,2 diol is going to be anti-addition. So you learn the simple reaction in simplest way. How do you say? How do you say? Like this? Surya Pandit, wonderful. Raj Chaudhary, okay. Now moving ahead, so Baeyer-Villiger oxidation, उसमें अब कुछ निकला. Baeyer-Villiger oxidation, ये Baeyer-Villiger oxidation होता है क्या? Chemical reaction that converts ketone into esters or cyclic ketones into lactones. Okay, you take a ketone, देखो ketone, and when you add peracid, एक ऑक्सीजन घुसाना है. Yes, you are going to get ester बन गया. ये कीटोन एक ऑक्सीजन घुसा दिया, so cyclic ester, this is called coprolactam, and this reaction is known as Baeyer-Villiger oxidation. And उसमें mechanism by definitely is not required for NEET examination, right? Aryan Dubey. Okay, so let us see. So whatever the name is seen on the name in the chart box, I'll use that name itself, right? Okay, anyways, KMnO4 K2Cr2O7, KMnO4 K2Cr2O7, they are such a strong oxidation reagents, okay, and you can see the strong oxidation, it is not specific, non-specific. It is going to give any functional group that you know in the organic chemistry to the carboxylic group. Any functional group to the carboxylic group. See how concise way I am giving you, that help you to do. So from the NEET channel, we are giving you the best out of the content. Bacho, those who are online, please like the session. And alkene or alkane gives carboxylic acids. Oxidation of alkyl benzene, it is going to give you benzoic acid. A condition kya? If you know this condition na, it is a super. A condition kya? Any alkylated benzene. Jadu, ye kya? Can I come in, sir? You please, you are welcome. So alkylated benzene gives you the benzoic acid condition number 1. जैसे at least one बेंजाइलिक हाइड्रोजन होना चाहिए. सो एटलीस्ट वन पाई बॉन्ड भी होना चाहिए. ये जैसे दोनों कंडीशन में, ओके, this could be one condition or this could be another condition. In these two conditions you are going to get alkylated benzene or the benzene substituted benzene is going to give you benzoic acid. So that is a super awesome, and this is a powerful concept that definitely I am expecting a question in NEET 2026 bacho, right? Hello Milan, good morning, good noon, good afternoon, whatever, right? Now you see oxidation of alcohols to carboxylic acid. Primary alcohol gives rise carboxylic acid, secondary alcohol gives rise ketone, tertiary alcohol gives rise alkene. Tertiary alcohols ऑक्सीडाइज नहीं करना है क्योंकि डिहाइड्रेट होगा. गुड मॉर्निंग, अरे बेटा अगेन सूर्य पंडित. ओके, नाउ कीटोन गिव्स कार्बोक्सिलिक एसिड. यूज पॉप-ऑफ रूल. सो व्हेन यू ऑक्सीडाइज कीटोन, एक्चुअली ऑल्डिहाइड आगे ऑक्सीडाइज करने तो कार्बोक्सिलिक एसिड मिलेगा बेटा, एंड कीटोन है ना आगे ऑक्सीडाइज करना मुश्किल है. सो कीटोन आगे ऑक्सीडाइज करने तो जैसे ड्रास्टिक कंडीशन में यू आर गोइंग टू गेट a carboxylic acid, so that ketonic group has to be broken, so the C double bond O group stay with the lesser number part. Yes, now let us see, reverse conversions are important in an examination. That's very important. Reverse conversions are very important. Thank you Loom, God bless you. Right, so बच्चों we will see this KMN over K2Cr2 over any alkene to alkane gives carboxylic acid. कैसे देखो, it is going to give you, okay, you use KMnO4 and you see this is the carbon and this is the carbon is oxidized, and you can break this bond and it is a super awesome conversion, and you are going to COOH, understand? So it is non-specific, anything it can break, समझ में आ रहा है क्या? And you see RCH2OH gives rise RCOOH, and RCH and R dash OH secondary alcohol, you are going to get RC double bond O R dash. ठीक है? Now if you want to take this tertiary alcohol like this CH3, see, it will not be oxidized better. Okay, you are going to get CH2 double bond C CH3 and CH3. It's very important. It's very important. Fine. Chromic acid, this is otherwise called Jones reagent. This is otherwise called Jones reagent. Okay. And a reagent H2CrO4 in acetone is called as Jones reagent. It is a selective reagent. It is a selective reagent. It cannot oxidize carbonyl group. It cannot oxidize carbonyl group. And you know, primary alcohol is converted into carbonyl. It is temperature dependent. I mean to say, lower temperature में जो जोन्स reagent है ना, mild oxidizing reagent का जैसे इस्तेमाल करना. And you use high temperature, it works as a strong oxidizing agent. Arey, you can say low temperature means any temperature lower than 0 is said to be lower temperature. Anything greater 0 is going to be higher temperature. You see, secondary alcohol to ketone and tertiary alcohols not oxidized, no effect. Yes, this session आग लग रहे हैं ना. Thank you very much बच्चों. And you can see this is temperature dependent. I want to compare. Whenever oxidation reactions comes now, you will be having a lot of confusions here. Don't worry, I will give you. What is this? PCC, pyridium chlorochromate. So this PCC, pyridium chlorochromate, इसका structure ऐसे आता है. This is a chromium beta. Okay. And pyridium chlorochromate का structure ऐसे है. Okay. And it is a PCC and it is a mild oxidizing agent, selective oxidizing agent, unable to oxidize carbonyl group. Are you getting or not clear? And primary alcohol is converted into carbonyl, secondary alcohol is converted into ketone, and tertiary alcohol is not oxidized. उससे क्या फर्क पड़ता जोन्स reagent का PCC का? जोन्स reagent and PCC purpose is same, but only difference is the temperature. At low temperature, mild oxidizing agent Jones का, at high temperature, strong oxidation agent जैसा होगा. And any temperature, this PCC is going to be mild oxidizing agent ही होगा. Are you getting or not? And now you can say PDC, the brother of PCC is PDC. Crystal clear. Very good. And this is dichromate with pyridium salt. It is called as a pyridium dichromate. And you see, PDC, it is a mild oxidizing agent, my dear students, and selective. It is unable to oxidize carbonyl group. And you see, primary alcohol to carbonyl group, and secondary alcohol to ketone, and tertiary alcohols are never be oxidized. Right? Now, I will compare Jones PCC and PDC. Both purpose is same. Okay, but PDC है ना, ये थोड़ा सा lower acidic conditions में इस्तेमाल कर सकता हूँ, थोड़ा सा flexibly होगा. PDC is less acidic than PCC, so that extreme acidic conditions नहीं is not required beta. This is the difference between PCC, PDC. PDC is more suitable for the oxidation of acid sensitive substances. Right? Crystal clear. And you see the uses of the reagents in this session. I think it is super useful. Okay, dear children, and I want to say here, it's time to take a minute break here, right? And I may ask you for at least a couple of minutes break so that I can drink water. I'll be back, and just stay tuned. In the class, we'll meet you after a couple of minutes, right? So a short break, beta. Hi Bacho, again I'm back after a short break. So we are waiting for you. Thank you, hello. And we'll see the slide again. This is the details about the PCC and PDC. PDC is the pyridium dichromate and here it is equal to PCC here. We are really waiting for, right? Now you can see this is a mild oxidizing agent and it is selective, unable to oxidize carbonyl group, and primary alcohol is converted into carbonyl, secondary alcohol is converted into ketone, tertiary alcohols are not oxidized. The chemistry of the uses of Jones, PCC and PDC, right? And this PDC is used in little acidic conditions so that we can use any acid sensitive groups are there. This is a better reagent. Any doubt? Right? Seriously waiting? That's good. Now, let's see Collins reagent. So many reagents, list by list, getting a lot of confusions. This is CrO3 in pyridine. It is a mild oxidizing agent. And CrO3, chromic anhydride, bacho, CrO3 in pyridine, and you use this as a Collins reagent. Sometimes you can say CrO3, okay, and concentrated H2SO4 and dry acetone. Similarly, CrO3, concentrated H2SO4 and aqueous acetone. So, what is the making a difference between these two? Okay, right here, Asta likes your answer. Surya Pandit, what is this? Okay, right. Let's see here. Whenever you see a dry acetone, you make it as a mild oxidizing agent. When aqueous acetone, you just say it is a strong oxidizing agent. That is the difference. Coming to CrO3 pyridine, it is a selective, unable to oxidize carbonyl group, dear children. And primary alcohol is converted into alcohol, secondary alcohol is converted into ketone. It cannot reduce, oxidize secondary, tertiary alcohol, right? And Jones reagent is equal to PCC is equal to PDC is equal to Collins reagent. So the chemistry and the usage of these three is same. Are you getting or not? Any doubt? So this kind of presentations can give you the best out of this, right? Now moving ahead, MnO2, coming to the close thing. MnO2, it is a mild oxidizing agent. MnO2 is a mild oxidizing agent. It is a specific reagent. Previous one जो है ना, they are selective reagents and this is a specific reagent and it is highly specific. क्या करता है क्या? Right beta, it is going to be allylic, benzylic and propergelic alcohols are selectively oxidized. So I will give you the example over here. This is your alcohol. The carbon is called allyl carbon and alcohol is there. This is called allyl alcohol. And this allyl alcohol is converted into aldehyde. And benzylic alcohol is converted into aldehyde. So that is the use of MnO2. Allylic and benzylic alcohols are converted into corresponding aldehydes, right? Any doubt? And another one is ozonolysis. We discussed about the ozonolysis. So mild oxidative ozonolysis, you can use zinc and H2O. You are going to get an aldehyde. And oxidative ozonolysis, you just use H2O2, you are going to get a carboxylic acid. You can use reductive, use lithium aluminum hydride, you are going to get corresponding alcohols. Fine. This is your ozonolysis. We already discussed it before this, what is ozonolysis and how it is done with various ones. And moving ahead, this is a periodic oxidation. It is there and it is important beta. So Asa and Surya Pratap and Surya Pandit, okay, come on, this uses of this is periodic oxidation. So you can use HiO4 or H5IO6 or the reagents that are used for this periodic oxidation, right? No doubt. Welcome, welcome. So it is going to be sodium peroxide also you can use. So when you use the book now, sir, HiO4 is there. You can also use H5IO6 and you can use sodium peroxide. And what it converts vicinal diols to aldehydes and ketones. So what is the condition? You can say here vicinal diol peroxide can cleave this and introduce OH group over there. And also diketone, you can use this one, you can use this one, you can get this one. And these are the conditions. C double bond O and COH, and also this can be cleaved here. Wherever you cleave the bond, you can make carbon to carbon bond is broken. MnO2. I will show you the MnO2 here. This is a mild oxidizing agent, highly specific. Allylic and benzylic alcohols are selectively oxidized. Allylic means this is allylic carbon, OH group is there, this is oxidized to give its corresponding aldehyde. And benzylic mean to say this is benzylic alcohol, this is converted into its corresponding aldehyde. Are you getting or not? Any doubt? Okay. So moving ahead, periodic oxidation, these are the conditions. If you use periodic oxidation, C double bond O and CH2, C double bond O, okay, periodic oxidation nahi hoga, usme hoga, usme hoga, usme hoga. That's what vicinal diols to aldehydes. Fine, any doubt? Now you can use the various examples and I'll give you a question. Periodic oxidation super important, NEET में सीधा इस्तेमाल करो. Cleavage of one bond require one molecule of HiO4 and you say this is your glucose. In this glucose you can use one HiO4, you can use HiO4, one more, so that 5 moles of HiO4 is going to be used. This number is important. And you are going to get a 5 formic acid and so 1 formaldehyde is formed. And when D-fructose is used, again you use 5 moles of HiO4, you are going to get 3 molecules of formic acid, 2 formaldehydes, 1 carbon dioxide. That carbon dioxide is coming from here. This carbon dioxide is coming from here. Clear? So everybody take a screenshot of this and कौन सा carbons, कौन सा product there है, and in one session, one slide it is given here. Everybody click and take a note of it. Everybody take a screenshot of this. 3, 2, 1. Got it? Fine. Now let's talk about here reductions. So how to go for a reduction? This is going to be super awesome. This slide is prepared. ये कर सकता नहीं कर सकता. When you talk about H2PT, Lindlar's catalyst, P2 catalyst, liquid sodium or liquid ammonia, sodium metal, liquid ammonia and NH3, sodium metal, and you can use Wilkinson catalyst. And H2PT can reduce alkene, alkyne, and it's a syn addition and non-selective. And Lindlar's catalyst, it cannot reduce hydrogenate alkene, but it can do alkyne, alkene तक कर सकता, and it is a syn addition, it's a selective. And you see P2 catalyst, it can just like Lindlar's catalyst, it's just like Lindlar's catalyst. Nickel boride is called P2 catalyst. Nickel boride is called P2 catalyst. And also liquid in sodium ammonia, liquid ammonia sodium metal, liquid ammonia lithium metal, just like Lindlar's catalyst. The difference is Lindlar's catalyst is syn addition, and sodium in liquid ammonia, it is said to be anti-addition, and it is selective. So when you make this cheat sheet or organized way of learning process, it can give you unmatched history of your writing organic chemistry questions in the NEET examination. Bachcho, here Wilkinson catalyst can do alkene, alkyne, but it is syn, but it is used for less hindered side. It is used for less hindered side. That is the remark of this. Okay, everybody take a screenshot of this, bachcho. 3, 2, 1, it can help you in quick revision process. And moving ahead, you can use preparation of alcohols by reduction of carbonyl compounds. So when you use a aldehyde, okay, a carbonyl reduction going to give rise to a alcohol. So aldehyde, if you use lithium aluminum hydride, it can be done. Sodium borohydride, it can be done. Rann nickel, it can be done. PDC, it can be done. Dibol H can be done. Diisobutyl aluminum hydride. And even ketone can also be reduced like this, but acid derivatives are not reduced by sodium borohydride. That's the reason why ester, it can reduce lithium aluminum hydride. Sodium borohydride, Rann nickel cannot be, okay, it is not effective with PDC, but Dibol H can do all the job. जैसे आपको lithium aluminum hydride इस्तेमाल कर रहे हैं. So in the chemistry, lithium aluminum hydride such a versatile reducing agent. It is used in mild acidic conditions, and it is little expensive as well. And the same is done by using diisobutyl aluminum hydride. It is given in the NCERT book. It can be done with ester, acid chloride, acids and cyanides as well. Okay, and when it is a cyanide, you are going to end up with an aldehyde. Okay, and let us see all the named reactions then. So let us talk about the comparison with lithium aluminum hydride, sodium borohydride, triphenyl tin hydride with alkyl halides can be primary, secondary, tertiary. So lithium aluminum hydride can reduce primary alkyl halide, and sodium borohydride cannot be done. It cannot be done, it can be done, right? But triphenyl tin hydride can be done. Now talking about lithium aluminum hydride. Lithium aluminum hydride can do with the secondary, and can do with the sodium borohydride, and can do with the triphenyl tin hydride TPH. जी सेकेंडरी हाइड्रोजन कुछ दिक्कत नहीं है. प्राइमरी का जो है ना सोडियम बोरोहाइड्रेट का कुछ प्रॉब्लम है, इट कैन नॉट डू. नाउ टॉकिंग अबाउट द टर्शियरी अल्काइल हैलाइड लिथियम एल्यूमिनियम हाइड्राइड, it do not, because alkene is preferably formed. That is important. Alkene is preferably formed, and it can do with sodium borohydride, and it can do with the triphenyl tin hydride. You can see the comparison. You guys study so sincerely, no worries about that, but you will be having a kind of confusions. If all the reasons comes on the same slide, then you will be doing great, right? Fine. Now organic functional group का जो conversions है ना, you are going to see all these conversions. जैसे root mapping रखने तो अच्छा होगा. This is given for your confirmation and for your convenience. And alcohol is converted into aldehyde, alcohol is coming from alkyl halide, and you can get alkene, alkane and epoxide, and aldehyde can be converted into carboxylic acid, cyanides can be converted into carboxylic acids. everything is available. Everything is available, you can do it. Reactions key, addition reactions होगा, substitution reactions होगा, oxidation, reduction, elimination, hydrolysis, okay, acetylation and esterification and other kind of reactions, right? That's good. Students, please, those who are online, please like this session and share with your friends, and let us see some neighborhood reactions. And whenever you do something now, you just make a noteworthy points and the cheat sheets like this. Okay, I don't want to confuse by showing this cheat sheet like this. It is you. Please, everybody take a screenshot of this. Click it. 3, 2, 1. Okay. So, when you prepare alkyl halides, haloalkanes and haloarenes. So, this is a cheat sheet by taking all the reactions in the NCERT book. And this one sheet now, it should be there with you just before going for the examination. You just read and go. So, last minute revision के लिए जब alkyl halide है ना, if it is treated with ammonia, you are going to get amine. Alkyl halide na, aqueous potassium hydroxide, SN reaction, you are getting alcohol. Alcohol है ना, KMnO4 carboxylic acid. Copper reduction, aldehyde. Aldehyde further oxidation, carboxylic acid, right? And this is alcoholic KOH elimination reaction, alkene banega. Bromine, you are going to get vicinal dibromide. You are going to get alcoholic KOH, फिर भी alkyne मिलेगा. Okay? You can use sodium amide. Okay? Alkyne. Alkyl halide sodium, you are going to get Wurz reaction, alkane मिलेगा. And it is treated with magnesium and dry ether. Grignard reagent is formed. It is carbon dioxide, carboxylic acid, and it is aldehyde. You are going to get a primary alcohol. It is going to secondary alcohol with aldehyde and tertiary alcohol with ketone. So, conversion related to alkyl halides. So, this you have to make. This you have to make. And I made it, and please take a screenshot everybody, so that neighborhood reactions एक बार revise करने तो हमारा काम हो जाएगा, right? And you can say alcohol के जैसे reactions हैं, alcohols P phosphorus and X2. You can also use SOCl2 for this purpose. You are going to get alkyl halide. Okay, you are going to get H plus H2O, dehydration, alkene मिलेगा, and copper 573 temperature. You are going to get ketone or aldehyde. You are going to get alkene if it is a tertiary. You are going to get aldehyde if it is a primary, and concentrated H2SO4 443 Kelvin. You are going to get an alkene. If it is 413 Kelvin, it is going to get ether. You see the temperature. You see the temperature, right? The difference between the temperature can give you the different reactions. And Jones reagent, acid, and all these reactions, lithium aluminum hydroxide, aldehydes and ketone. Okay, you can use PCC or CrO3, aldehyde and ketone. Everything in one shot. Everything in one shot. The reactions are shown like this. Everybody take a screenshot of this. 3, 2, 1, come on. Hope this is visible to you. And similarly, aromatic amines and benzene diazonium chlorides, and I will show you those reactions as well. Okay, so all neighborhood reactions, Finkelstein reaction. Okay, all neighborhood reactions एक बार आपके लिए छोटा सा revision देना चाहता हूँ. So alkyl halides when treated with NaX, okay, in the presence of acetone, you are going to get alkyl halide. So you can say alkyl chloride, Finkelstein reaction. Now you can see Schwarz reaction. Finkelstein reaction. Now you can see Schwarz reaction. Schwarz reaction. Can you visualize? Yes, this is a Schwarz reaction. So preparation of alkyl fluoride, reaction of metallic fluoride such as AgF, HgF2, Hg2F2, COF2, SbF3 with alkyl halide. You can see alkyl chloride taken with AgF, RCl, AgF. Okay, you're going to get alkyl fluoride. That is called Finkelstein reaction. Any doubt? एक minute. So can you all see me? Confirm? Yeah. Can you visualize? Aldol condensation, what we discussed, yeah, that's very good. That's very good. Aldol condensation is reaction that occurs when alpha hydrogen of aldehyde react with dilute base to produce beta hydroxyaldehyde is termed as aldol reactions. Right? Well, now Boltzmann reaction, actually it is used to prepare fluorobenzene. So you can see aniline, it is subjected for diazotization and it is going to give rise diazotized compound with HBF4. So diazonium borofluoride is formed. This diazonium borofluoride is heated to give rise fluorobenzene. This reaction is called as Boltzmann reaction, and this is only the best way to prepare fluorobenzene. You can't use a Schwarz reaction for this because it is a halogen, अलग method इस्तेमाल करना बेटा. And also see carbalamine reaction. So any primary amine, when it is treated with CHCl3 KOH, you are going to get isocyanide and it is unpleasant smell. So it is a test for a primary amine. So alkyl primary amine or aromatic primary amine, even aniline can react with this. Aniline react with chloroform and potassium hydroxide. You are going to get phenyl isocyanide. It is unpleasant smell. Test for amines. Okay, and you can see Cannizzaro reaction. So what is this Cannizzaro reaction? It is a self-oxidation reduction process. So when aldehyde, if it has alpha hydrogen, if it is treated with an alkali, it undergo condensation. If the aldehyde do not have alpha hydrogen, it undergo oxidation or reduction. One molecule is getting oxidized to form an acid, another molecule is getting reduced to get alcohol. So it is a disproportionation reaction, right? So this is what is called as a Cannizzaro reaction. So benzaldehyde gives rise benzoic acid, benzyl alcohol, and Clemmensen reduction, it's a super important beta. So Clemmensen reduction and Wolff-Kishner reduction both are contrast and the purpose is same. So aldehydes and ketones can be converted into alkanes via Clemmensen reduction, because when it reacted with zinc amalgam in HCl, it is going to reduce to give rise corresponding alkane. So this is what is called as Clemmensen reduction, zinc amalgam, you can say this. And the same reaction can be done by using catalytic hydrogen, PT, and high pressure H2 you can use. PDC, and initial product is alcohol is further hydrolyzed. Only benzylic ketones are fully reduced to alkanes, but everybody is not. This is only the only benzylic aldehydes ketones, okay, only benzylic ketones, but not everybody. So the noteworthy points are also very important. हर reaction का ऐसा मत जाना बेटा. And talking about ETOD reaction. So whenever ETOD reaction means a toluene is treated with CrO2Cl2 and it is going to give a chromium complex, and it is further hydrolysis gives rise benzaldehyde, and this chromium complex का जो structure है NCERT से निकला, this is also important for NEET. What is that chromium complex here? What is that chromium complex here, right? And this is about the ETOD reaction. Any doubt? All named reactions. So आज का session का जो topic है, make your organic chemistry reaction so simple so that I am following the strategies and a one-shot session. If you have any doubts, please talk to me and use this session in the best way. Okay, Asta, Surya and Betu, are you there? And all the students, Pandit ji, and Friedel Craft alkylation. Benzene has 5 golden reactions. I just want to show you and I'll make you to understand. In that, one reaction is Friedel Craft alkylation. Benzene react with alkyl chloride in the presence of AlCl3. Okay, you can say CH3Cl. In the presence of AlCl3, you are going to get alkyl benzene. This is called alkylation. Acyl chloride and AlCl3, acylated benzene, you are going to get acylation. Friedel-Crafts acylation and Friedel-Crafts alkylation. Okay, and Gabriel thalamide synthesis is a super important amine preparation. This Gabriel thalamide synthesis reaction is used only for, it is used only for preparation of primary aliphatic amine, used to prepare primary aliphatic amine, primary aliphatic amine. You cannot use it for aromatic amine क्योंकि ये जो reaction है ना, thalamide जो reaction में, ये thalamide जो hydrogen is acidic in nature, ताकि एक HKOH से react होने तो ये potassium salt बनेगा. ये potassium salt nucleophile के जैसे react करते हैं ना, it is going to react with alkyl halide. This is the key point, and this is substitution by molecular reaction. And this is substitution by molecular reaction gives rise alkylated benzene. So alkylated thalamide, and this alkylated thalamide is hydrolyzed to give rise primary amine. And assertion reasoning type questions are also very important. Why Gabriel thalamide synthesis is not used for preparation of aromatic amine? अगर आपको aromatic amine चाहिए तो ये क्लोरोबेंजीन इस्तेमाल करना. हैलोबेंजीन्स डू नॉट पार्टिसिपेट इन न्यूक्लियोफिलिक सब्स्टिट्यूशन रिएक्शंस. आगे बढ़ना मुश्किल है, ये रिएक्शन नहीं देंगे. आर यू गेटिंग और नॉट क्लियर? फाइन, ओके. नाउ टॉकिंग अबाउट Gatterman reaction, benzene diazonium chloride, when it is treated with just copper powder and HCl, it is going to give us chlorobenzene. This looks like a Sandmeyer reaction, but it is a Gatterman reaction. Purpose is same. And so Gatterman reaction is different. Gatterman-Koch reaction is different. You can see now this is a Gatterman-Koch reaction. So benzene with CO and HCl in the presence of CuCl and AlCl3, you are going to get benzaldehyde. This is there in the NCERT just below the ETOD reaction, and CrO3 reaction, Gatterman-Koch reaction is there. You should have that tremendous command about the NCERT textbook, everybody, right? Gatterman-Koch reaction. Talking about Reamer-Tiemann reaction. Reamer-Tiemann reaction. This is a phenol when it is treated with CHCl3 and sodium hydroxide, where you have seen a mixture of chloroform and potassium hydroxide. Mixture of chloroform and sodium hydroxide is used in phenyl isocyanate test, carbylamine reaction, and Reamer-Tiemann reaction. See, and you are going to get an intermediate. अरे बेटा intermediate क्या होगा? And that is also one of the options in the NEET examination question. And it is treated with sodium hydroxide to get the salicylaldehyde. This is about the Reamer-Tiemann reaction. You are back, lage raho beta. And this is RTR and Rosenbaum reduction. It is a reduction whenever acid chloride is treated with H2PdBaSO4 chlorine is removed and you are going to get aldehyde. So this is a reduction reaction. This is called as a Rosenmund reduction. Fine. Any doubt? Right. One more. Sandmeyer reaction. Benzene diazonium chloride, whenever treated with aniline. Okay. So this is actually, I want to expand this. Same reaction only. So this is your aniline, and whenever it is treated with NaNO2 and HCl, better you have to maintain 0 to 5 degrees centigrade. You will be getting benzene diazonium chloride, and if it is treated with CuCl or Cu2Cl2, you are going to get chlorobenzene. Okay, so this reaction is known as Sandmeyer reaction. Gatterman reaction का जैसे होगा, right? Any doubt? Now Stephen reduction. Cyanides are converted into aldehydes directly here. So cyanide, when it is treated with SnCl2, you can get some intermediate complex. Further hydrolysis, it is going to give rise aldehyde. Cyanide is converted into aldehyde. That is a direct reaction. Fine. And Williamson ether synthesis, it's a very important. Alkyl halides treated with sodium alkoxide. Okay, so this is sodium alkoxide undergo perfectly SN2 reaction to give rise ether, and the ethers that are formed by these alkyl halides, primary alkyl halides can give, secondary alkyl halides can give, tertiary alkyl halides do not participate in this Williamson ether synthesis. In the NCERT, the combination of reactions is given, you just go ahead with that. And Wolff-Kishner reduction, this is a brother of Clemmensen reduction. In Clemmensen reduction, you use sodium zinc amalgam. Here it is a basic medium. You can see NH2, NH2, KOH, you are going to see C double bond O will be converted into alkane. Cyclopentanone is converted into cyclopentane. So this is what is called as Wolff-Kishner reduction, my dear children. Right? Any doubt? Asa, Surya, Pandit. Okay. Now Wurtz reaction. We discussed about this Wurtz reaction. So alkyl halide, when it is treated with a sodium metal to give rise higher alkane, this is what is called as Wurtz reaction. For this Wurtz reaction, my dear children, alkyl iodide is more reactive than alkyl bromide is more reactive than alkyl chloride is more reactive than alkyl fluoride. Actually alkyl fluoride Wurtz reaction में involve नहीं होगा. And also Hoffman bromide reaction descending conversions में हम देखे हैं ना. So when amide is treated with Br2 and sodium hydroxide, ruthlessly C double bond वो हटा देना, amine मिलेगा. So descending conversion में इस्तेमाल कर सकते. So acetamide gives rise methanamine, propanamide gives rise ethanamine. क्या फर्क पड़ता है? Simply ये हटा दो. Right बेटा? So this is about the Hoffman bromide reaction. Now haloform reaction, we already discussed this haloform reaction. So any methylated ketone is eligible whenever it is treated with sodium hydroxide and halogen. It could be chlorine, chloroform, it is going to form bromoform. If it is iodine, iodoform. क्या काटना है? यहाँ पर काटना है. So it is going to be CHBr3. Fine, this is about the haloform. This is the haloform reaction is used for distinction test among the organic functional groups. Only methyl ketones and methylated secondary alcohols give this test. And ethyl alcohol is the only primary alcohol gives rise this haloform reaction. Sir, conditions भी है. ठीक है बेटा? And I am coming to HVZ reaction, Hell-Wohlhard-Zielinski reaction. In this, alpha halogen of the carboxylic group is going to be halogenated when carboxylic acid is treated with halogen in the presence of red phosphorus. So Br2 red phosphorus. This is what is called alpha carbon यहाँ पर halogenate करना, and this gives a lot of synthetic application. If you use this in the potassium hydroxide, you are going to get carboxylic group, you are going to get alpha hydroxy carboxylation, okay, and you can go ahead with various things, and synthetic chemistry may we can discuss it, no problem. And you can see, and whenever Grignard reagent is there, I always say make a tree like this. Grignard reagent react with formaldehyde primary alcohol, Grignard reagent react with ketone gives rise tertiary alcohol, Grignard reagent react with various functional groups. I am going to give you Grignard reagent reacted with carbon dioxide gives rise carboxylic acid. Why not? All the reagents are there in the NCERT. Here you can use it, here you can use it, here you can use it. Why not? It can be acid derivatives as well. So everybody take a screenshot. Everybody take a screenshot. 3, 2, 1. Click it. And also you see, and this is the actually one. It is the question asked in 2025 NEET examination. Everybody is banging their heads. It was a nice question. So this is a cyanide and C double bond O. Excess of methyl magnesium bromide is added and it is hydrolyzed. So excess of methyl magnesium is added. You are going to see the formation of this is the one. CH3 and it is going to be C double bond and it is going to be CH3, isn't it? Now I want to cleverly hydrolyze this, nothing, cleverly hydrolyze this. You are going to break this bond and you are going to break this bond. I mean to see it become OH. So you are going to see C double bond O and CH3 and it is going to be OH. So excess means it can react because jinda nahi CH acid hydrolysis is going to react with already excess of methyl magnesium bromide is there. So I want to say this is the one, this is the one is the answer. Fine, clear, you can see this. So uses of Grignard reagent is going to give you a super important conversions, right beta? And yeah, for that Grignard reagents are super important. You have SN1 and SN2, everything mechanism based reactions. I don't want to take you to into the so many conversions, right? And I will show you the 5 golden reactions of benzene. These are the 5 golden reactions of benzene beta. देखो, benzene, however, it has 3 double bonds in it. It do not behave like an alkene. So it do not undergo addition reaction, rather it undergo substitution reaction, right? So benzene, when it is treated with chlorine and it is going to give a chlorobenzene, उसमें electrophile क्या होगा? Cl plus is the electrophile and this reaction is called as a chlorination, right? And the benzene, when it is treated with HNO3H2SO4, you are going to get a nitration. So it is the electrophile. Which of the following is an electrophile in this reaction? Like that, you will be having a question in NEET examination. So this process is called as a nitration. And the benzene, it is treated with SO3 and H2SO4. Sulfonation takes place. You are going to get SO3H plus is an electrophile. And you know, all the reactions are irreversible. This is the only reaction that is irreversible. Right, beta? And you can see when benzene treated with alkyl chloride in the presence of AlCl3, you are going to get alkyl benzene. This is called as Friedel-Crafts alkylation. उसमें electrophile क्या होगा? R plus होगा. Right? And benzene, when it is treated with RCOCl in the presence of AlCl3, you are going to get acylated benzene. So this is called as Friedel-Crafts acylation or C triple bond O plus मिलेगा. Right? And these are the various electrophiles that you can see. Clear? Any doubt? And sometimes Friedel-Crafts alkylation, polyalkylation can take place. Friedel-Crafts acylation, polyacylation takes place. These are the 5 golden reactions of benzene. Electrophilic aromatic substitution reaction. Fine. And I want to discuss about the direct to influence. Now, the comparative picture between the Friedel-Crafts alkylation and Friedel-Crafts acylation. In alkylation, you are going to get rearrangement of the carbocation takes place and the polyalkylation takes place. In Friedel-Crafts acylation, rearrangement do not takes place and polyacylation do not takes place. That's very important. And also, directive effects in electrophilic aromatic substitution reaction, that is a super important concept for any kind of examination. This is what is called anisole. When it is treated with Cl2AlCl3, you are going to get ortho, meta and para. You will be having ortho and para or the major and meta is the minor. Among ortho and para is going to be the major due to steric reasons. I want to say why it is going to be strongly activating. जब activating हो group आ सकते हैं ना, so it is going to be ortho and para directors. So strongly activating groups OH, O or NH2, NR3 comes into this, and moderately activating groups है ना, SH, SR and ester groups and amide groups, and weakly activating group है ना, methyl and alkyl and phenyl groups. And also you see here one more NO2, nitrobenzene is there. You are going to say the meta product is the major. Whenever ring is deactivated, whenever positive mesomeric effect is there, ring is activated. Negative mesomeric effect is there, ring is deactivated. So let us see the ring deactivating, strongly deactivating. In this strongly deactivating CF3NO2 NHE3 plus comes into the picture, and moderately deactivating carbonyl groups comes into the picture, acid and acid derivatives comes into the picture. But here halogens, of course they are weakly deactivating, but they are exceptionally ortho and para directions due to they have strong inductive effect and weak mesomeric effect, right? And this is about the direction group. So this is one picture which can show you the overall version of the activating, deactivation and the directing. Everybody take a screenshot, click it, activating and deactivating. Any doubt? If you have a doubt, please let me know. And moving ahead, so example, how do you convert this into this? And here one thing, this is activating and this is deactivating. Whenever on the benzene, both activating and deactivating are there. Focus on the activating and listen to what activating group says, right? So that it is going to be the measure. Understand? So this is the direction with respect to the activating. Okay, like that you can do so many conversions. You can say if this is a one, it is given as deactivate and it is alkyl group na hyper conjugation ka hisab se it is going to be activating. So you have to listen to him. So ortho and para. So the product that is going to be in the Friedel-Crafts acylation with respect to this. Fine. Now, if you take conflicting directing effects, whenever this is a CH3 activating N dimethyl amine group, so here it is a strong activating and it is a weak activating. Whenever strong activating and a weak activating is there, listen to the strong activating. इसका हिसाब से आप दे सकता हूँ a product as a major product. Whenever stronger activating is there, its effect is greater than this weaker activating. Stronger activator has a greater influence in the substitution position accordingly, right? So similarly, you have so many slides that can show you, and आज के लिए I just want to discuss इतना ही, and और एक सेशन हम शेड्यूल करना चाहता हूँ सिर्फ क्वेश्चंस डिस्कस करने के लिए. ओके, आज क्वेश्चंस बना के रखा, बट आई वांट टू गिव यू द बेस्ट आउट ऑफ दिस. So hope today you enjoyed all the conversion, how we did it and what it can be done, various reagents, oxidation, reduction and ascending conversion, descending conversion, aromatic conversion, everything. And I am done for today. We'll meet with more stuff in the upcoming session. Please like the session, share with your friends, subscribe to Infinity, the Sri Chaitanya YouTube channel. Thank you very much. Thank you.